Hi all, this is Shweta Reddy, working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. Today, in this video of wireless communication, we are going to see a topic on Rake Receiver. So, let us see what is Rake Receiver in detail. So, today in this particular lecture, we will be going to discuss about Rake Receiver. So these are the outlines. We are going to start up first. We are going to start up with the introduction. Then we are going to discuss about multipath. What is multipath, that and all. Then we are going to discuss about what is rake receiver, which will be followed by the block diagram description of that receiver. And then we are going to discuss the working principle or working of rake receiver, which will be followed by several applications of that receiver. And finally, we are going to conclude by discussing some of the advantages as well as disadvantages associated with this rake receiver. So let us start with this contents. So coming to the introduction part of this rake receiver, the basic idea of rake receiver was actually being proposed by Prince and Green in 1956. So it is basically a CDMA based receiver, that is code division multiple access based receiver. Or you could also say that this rake receiver would have been used in the CDMA based systems, where we are using the spread spectrum communication, that and all. So it would have been proposed to combat with the multipath fading effect, since this multipath fading effect is responsible for this degradation of our signal. So it would have been developed to reduce this effect. So it is achieved by using several sub-receivers. These sub-receivers each are delayed slightly to tune into the individual multipath component. Since these multipath components are arriving from different paths, then obviously the time at which they are going to receive the receiver, that will be different. So we just have to use these several sub-receivers, which are tuned to slightly delay the multipath component. About this multipath component, we will be seeing in upcoming slides. So now, as of now, just remember this. So coming to multipath, first of all, we should understand what is multipath. Can anyone say what is multipath? So multipath occurs when the radio frequency signals arrives at the destination by a different path due to the reflected transmitted signals moving from fixed to object. So suppose if we understand this, this is our transmitter and this is our receiver. So when the transmitter will going to transmit the signals and the receiver is going to receive the signals, which are reflected and diffracted as well as scattered, which are reflected, diffracted as well as scattered from multiple components such as buildings, trees, etc. So here at this particular receiver, we will be having multiple components. One is your direct path and the other is combination of multiple components. So if we closely observe that this is the particular figure, in this particular figure, it is basically reflecting the amount of amplitude or signal strength we are receiving at the receiver, and these are your tau 1, tau 2 and tau m. Up to tau m we have. These are basically signifying various delays at which we are getting this multiple copies of the same signal. So obviously here at the particular tau 1 we will be having this peak, and at particular tau 2 this peak is actually for your second multipath component. And similarly you have till m, that is if we consider that we are having m multipath components, then this peak is basically representing the maximum amount of signal received at tau m delay. So rake receiver is a diversity receiver because the multipath components are statistically independent or uncorrelated if the propagation delay is greater than the chip period. That is, the propagation delay T of PD. PD is nothing but the propagation delay. If T of PD is greater than TC, so it has been observed that if the propagation delay is much greater than your chipping duration, or it is at least equal to TC, or it is greater than TC, then in that particular case, several multipaths will be less uncorrelated or highly uncorrelated. So it will be easier to catch away these uncorrelated signals or frequency components. So if the signal components arrive more than the duration of the chip period, then the rake receiver can be used to resolve and combine them, since they are highly uncorrelated and it is an observed phenomena as well. So if the multipath components are arriving greater than the chipping sequence or single chip duration TC, then they will be highly uncorrelated. So the rake receiver uses multipath diversity principle, that is at the receiver how we will be going to combine them, how we are going to combine them are basically applying them in MRC techniques. MRC is nothing but maximum ratio combiner. So what is it we are going to discuss further? As of now, just remember this. So first of all, we have to discuss what is rake receiver. So a rake receiver is a radio receiver which has been designed to counter the effect of multipath fading. And how we are going to do that? So to do that, first we all need is to understand the block diagram structure. That is what it is made up of and how we are going to nullify the effect of multipath fading, that and all. So since the rake receiver would have been employed in your CDMA system, CDMA systems are nothing but code division multiple access systems. So here RT is basically a CDMA received signal at the receiver. So since the signals are coming from multiple paths, so this is your M1T, M2T up to MMT. These are representing different multipath components, and they would have been passed to the corresponding correlator, which would have been tuned to the particular peak associated with that multipath component as such. And we have already discussed that the first multipath component is arriving at tau 1 and the second multipath component is arriving at tau 2, and up to mth time, that is tau m, at the particular tau m we will be receiving this mth signal component. And all these correlators are basically tuned, that is time shifted or delayed version of that particular signal. Then the outcome of this correlator is representing by this particular symbol, that is your Z1, Z2 and up to Zm. Then they will be passing through this weighing network, and that weighing coefficient would have been given as alpha 1, alpha 2 and up to alpha m. So these are the weighing coefficients. These weighing coefficients are basically being defined on this basis of how much amount of SNR level, that is signal to noise ratio level, we are receiving in that particular multipath component. If the received signal to that is SNR, if the received SNR of any given multipath component is high, in that particular case, we are going to assign the higher value to that particular component. And if we are getting lower SNR, then we are going to assign this lower value of this weighing factor. Then after that, all these things would have been passed to the summer, where we will be performing linear combination of all these components. And after proper normalization, we are going to pass it to an integrator in order to evaluate the signal strength or power of that particular signal. And if that particular signal is will be equal, that is if the particular signal will be into Z, on that basis of Z we are going to determine which particular bit would have been received, that is whether it is 0 or 1, depending upon the threshold value. I mean, for simplification, if we consider the threshold value would be equal to 0, then if the value of Z is greater than or equal to 0, then the received symbol would have been determined as 1. And if it is lesser than threshold value 0, then it would have been evaluated as 0. So this is how we are going to receive our signal empty, which would have been transmitted from the transmitter. We will discuss detail detail working of rake receiver in the next coming video. So we will discuss the working of rake receiver in detail in the next coming video. Thank you all.